Double angle formulas. Here we go. I would say that this is the most common. This is the most common section for me to get the IDK response on the test. Again, if you write IDK, you'll just infuriate me, and I won't know what to do other than just take out the red pen and start making marks. So these aren't that difficult, but people just seem to struggle with that. I don't know what the deal is. I haven't figured it out yet, so we'll just try again. So if you want to know sine of a double angle, say 2a, you don't have to write this part down, but I would like to go back to our sum and difference formulas. I could write that as sine of a plus a, right? And I could use my sum and difference formula to write sine of a times the cosine of a plus the sine of a times the cosine of a. Those are the same, aren't they? So get 2 times the sine of a cosine of a. So it changes it from a double angle to a single angle. This is very useful for us when we're solving trigonometric equations, which you're going to have to do. It's also helpful to us in calculus. We could use a similar type of formula. I won't write it out just for the sake of time. Cosine of a double angle is equal to cosine squared of the angle minus sine squared of the angle. Or 2 times cosine squared of the angle minus 1. Or 1 minus 2 sine squared of the angle. This is just one of those times during the year where I see people write stuff down and come in to test. I realize at this point that people have no idea what's going on because they'll write all 3 formulas down and they'll like do triple the amount of work and they still won't have one of them right. So how many formulas do you have to choose for the middle one? 1. You just choose 1 of the 3. You have 3 choices. You choose 1. And so, because you just choose 1, you just choose the one that's your favorite. I like to choose the very last one. Okay? That's the one I like to use. I'll show you why in a little bit. Tangent of a double angle is equal to 2 tangent of that angle divided by 1 minus tangent squared of that angle. I just used my tangent sum formula from yesterday in order to come up with that because I add the tangents together on the top, right? You get 2, and I multiply the 2 together on the bottom to get tangent squared. So you can just use that formula from yesterday to come up with that. All right, so we get to the example that you're going to have to do in your assignment and on your study guide and on your test. Again, this is the most common IDK question that I get on the test. Please don't answer IDK. It says, given that cosecant of an angle is equal to 2, we want to know sine of the double angle, cosine of the double angle, and tangent of the double angle. Is the angle itself equal to 2? No. Do you know what the angle is? No, we don't. We could actually figure it out by doing inversing, but that's not important. We don't know if it's 30-degree angle, 80-degree angle, 60-degree angle, 25-degree angle. What we're going to use is our formulas in order to determine this piece. So I'm going to write sine of the double angle, cosine of the double angle, and tangent of the double angle. And I'm going to start with the very first one. On the test, when you see sine of 2x, cosine of 2x, and tangent of 2x, I won't say use your double angle formula. A light bulb needs to go off in your brain to say, oh, it's double an angle. Therefore, I'm going to turn to my very helpful sheet that Mr. Gentz put together for me. Thank you very much, Mr. Gentz. You're welcome. And I'm going to look at that sheet, And I'm going to find the one that says double angles. I actually have students that will color code these so they can say, oh, that's where I go to the blue one. That's where I go to the red one, okay? So you decide how you want to do that. But right now, the double angle formula, I will choose that one right there. 2 sine of an angle times cosine of the angle. So that's what I'm going to write down. Doesn't matter whether you use A or X, just be consistent. In order to evaluate this formula, I have to know sine of X and cosine of X. Does the problem give me either one of those? Can I determine one of them? How? Since I have cosecant of X is equal to 2, therefore, sine of X is equal to 1 over 2. Oh no, I don't know what cosine is. Bueller. Took the reciprocal of that because cosecant and sine are reciprocals. Use the things, the whatchamacallits. Let's be more mathematical in our explanation. One of those formulas. Okay, now it sounds like physics. Let's get to math. Trigonometric identities, the Pythagorean ones. Yes, sine squared plus cosine squared is 1. Woo! Got it. It's almost like you guys did the problem on your own. Do you remember this from your final exam? So, square sine, what do you get? 1 over 4 plus cosine squared of x is equal to 4 over 4. Subtract cosine squared of x is equal to 3 over 4. Square root both sides. Cosine of x is equal to... Yes, and I appreciated that, but I needed to see this part first so people would know what was going on. Oh no, plus or minus, what do I do? Draw out the dealio. Or, say it, Darren. We know we're in the second quadrant. The problem says it, right? So if I'm in the second quadrant, cosine is negative. So I use 2 times 1/2 times the negative root of 3 over 2. What is 2 times a half? 1 times negative root of 3 over 2 is negative root of 3 over 2. That is the exact value of sine of 2x. Yes. All right, now I'm going to grab another formula. I will say the next two are super easy compared to the first one. Because you already know sine, don't you? Yeah, so we have 1 minus 2 times, square your sine value. What's sine squared? 1 over 4. What's 2 times 1 over 4? What's 1 minus a half? What's up? Depends on how you look at it. Okay, tangent of 2x. I've got an idea. I don't like the formula. Raise your hand if you don't like the formula. Fine, use it. I don't want to use it. I'm going to do sine of 2x over cosine of 2x. This is important. A lot of people get to this point and they will make a mistake. They don't do sine of 2x over cosine of 2x. They do just sine of x over cosine of x. They'll say, oh, I'm going to take 1/2 and divide it by the negative root of 3 over 2. We have to do sine of 2x divided by cosine of 2x. So you tell me, what is the sine of 2x? Yeah, I grab it from right here, negative root of 3 over 2. Divided by 1 over 2. As Kelsey said, I multiply by 2. Good to have you back, Kels. I get negative root of 3. Piece of cake upside down. What's up? Thank you for saying the whole word. Yes, for cosine. So, no, I'm not doing 1 minus 2. What is 2 times a 4? 1 half. Better? All right. So, the first part of your assignment will be double angle formulas. Let's move to half angle formulas. Yes. Oh, Tigers. Yes. No. We'll decide by 1 o'clock. I hope they do its best for everybody. That means we run. I'm ready to run. Sure. I do the warm-up lap and the cool-down lap. All right. Every year I ask for a coach's event. They don't put one in. You know what? I remember the first two. I remember sine. I remember cosine. I don't remember tangent. So fortunately, I put together this handy-dandy reference sheet that has half-angle formulas. Looks like for tangent, I have 2 options. Of those 2 options, how many do you think you choose? 1. That's what we'll do. So there's our sets of formulas. The plus and minus might make you angry. It should not make you angry. It's not that big of a deal. We're going to show you 2 examples of how you can apply this. Example number 1, cosine of 15 degrees. Have we done this problem before? When did we do it? Thank you. Can you please be more specific? Very good. When you did a difference formula, cosine of 45 minus 30. But I can use a different approach now. Instead of a sum or difference formula, I can use a half angle formula. 15 is half of what? 30. So I'm going to do the cosine of 30 over 2. On the test, I will not tell you to use the sum and difference or the half angle formula. You have to decide. I will work both problems out so that you can choose either method and make sure you're coming up with the right answer. You get a choice. But I'm not going to tell you what to do. You got to figure that out. Okay? So I have cosine of 30 over 2. So therefore, what is the angle that I use in this problem? What is A? A is 30. Okay? So I start out with my formula. Plus or minus the square root of 1 plus the cosine of A all over 2. Here's where the plus or minus comes in. Can you guys tell me if it's cosine of 15 degrees, is 15 degrees in the first, second, third, or fourth quadrant? First quadrant is cosine positive or negative in the first quadrant. So therefore, I will choose positive. So I have the square root of 1 plus. What is the exact value of cosine of 30? Oh no, I need to draw my unit circle. Thank you. I've been working. Very good. So I have the root of 3 over 2 and 1 half. So those are my terminal point. That's my terminal point. Cosine is the x value or the y value. So I choose square root of 3 over 2. That's the value you need to come up with on your own. All divided by 2. Can I leave my answer like that? Why? Okay, two common answers at this point. Number one, fraction side of fraction. I'm sorry, a square root inside a square root. You can actually leave square roots inside one another. That's okay. Well, what you may not do is have a fraction in a fraction. That's called a complex fraction. So I will create one fraction up here. I have the square root of, this would be 2 plus the root of 3 over 2. Now that I have a fraction over a fraction, I will multiply by the reciprocal. I change 1 to 2 over 2. And I get the square root of 2 plus the root of 3 all over 4. Now, you have to take the square root of the top and the bottom. You cannot leave a square root of the denominator. So what is the square root of 4? 2. Can you take the square root of the top? So just leave it as the square root of 2 plus the root of 3 all over 2. And it's a big day because it's the first time you've ever written a square root inside a square root. And so we'll remember this day. It will go down in history. I think you should take a picture, have your parents put in your scrapbook. When I come to your graduation party, I want to look up that nice, scrapbook, and I want to see some of your first days. Well, you just think it's like, the first time you whatever, whatever, Ryan. We move on to sine half angle point, pi over 8. You guys probably want to convert this to degrees, right? Oh, all right. Pi over 8 in degrees is? What's pi over 4 in degrees? 45. What's half of 45? So we have 22.5, or the sine of 45 over 2. Okay. So you can see that my angle is 45. So my formula is plus or minus the square root of 1 minus the cosine of my angle, 45 degrees, all divided by 2. Pi over 8, which quadrant? 1. Will it be positive or negative? Positive. So I choose the positive result, square root of 1 minus, what is the exact value of cosine of 45? Wow, you guys are getting smart. Can I leave my answer like that? No. I have a complex fraction. Find common denominators. So I have the square root of 2 minus root of 2 over 2 divided by 2 over 1. Multiply by the reciprocal. We get the square root of 2 minus root of 2 all over 4. You can take the square root of the top. You take the square root of the bottom. I get the square root of 2 minus root of 2 all over 2. It is exciting, and since you said that, let's take out our calculator. Sine of pi divided by 8, make sure you're working in radians. Mode, change from radians to degrees, or degrees to radians. I press sine of pi over 8. I get 0.3826834324. Your calculator does something amazing with calculus in order to come up with that value. It doesn't do what we did. And what we did is rather impressive. Watch. We will take the square root of 2 minus the square root of 2 and divide it by 2. Exactly the same. Now, before I give you your assignment, I just want you to appreciate one last aspect of this. True or false? We know the exact value of sine of 45 degrees. What is it? Root of 2 over 2. Do we know the exact value of sine of 22.5 now? Yeah, and now that we know the exact value of sine of 22.5, we would then be able to find the exact value of sine of 11.25, correct? And then half of that, and half of that, and half of that. So we could bring these all down to very, very small values. So then, all of a sudden, once you can find the exact value of, say, sine of 1 degree, then all of a sudden, you can find the sine of 31 degrees. Because you could do the sine of 30 plus 1. And that will create some really, really good estimations. Big deal. I've got a calculator. Oh, good. Good for you. What about the previous 3,000 years when people didn't have access to any of that technology, and they would have to come up with numerical approximations by hand, and this is a great way to do it. So, here's your assignment. Go to work.